A student is moving in the hall at 7 meters per second. Another student darts out in front of the first student and they must stop moving to avoid a collision. The first student is brought to a stop in 0.8 seconds. Determine the acceleration of the student. So for this problem, we need to use our acceleration equation, which is A is equal to Vf minus Vi over t. And so let's list our variables down the side. We have A for acceleration, Vf for final velocity, Vi for initial velocity, and t for time. If I pull up from my problem the important information, I see I have 7 meters a second. I see that they stop moving, so they have to come to a complete stop, and that takes them 0.8 seconds. Overall, I'm looking to determine the acceleration. So if I list my variables, acceleration is what I'm looking for. Vf is the final speed, which in our case is 0 meters per second. Vi is the initial speed, which in the problem says he's traveling at 7 meters per second. And then the amount of time it takes him to get from 7 meters per second to 0 is 0.8 seconds. Now for this problem, all I have to do is plug some stuff in. So A is equal to Vf, 0 meters per second, minus Vi, 7 meters per second, all over my time of 0.8 seconds. If I plug that into my calculator to solve for acceleration, I should get a negative 8.75 meters per second squared. And so this negative comes from the fact that we're slowing down, so we're decelerating. And then this meters per second squared unit, on top here we have meters per second over seconds. And if we think about that unit, meters per second, which can also look like this, which can also look like this. So that's where that meters per second squared comes from.